Hello everyone. Today we are from Group 2. We will give our presentation about carbohydrates. Group 2 is consists of myself, Muhammad Tafabren Naja Aurel Sulaksono, Anindya Putri Dasara Karya, and Thierry Muhammad Arkezuman. And today we will gonna discuss about 5 topics. The first one is monosaccharide reduction, hydroxyl group reaction, glucose structure determination, disaccharide, and last but not least, polysaccharide.
Okay, so for the first topic is about monosaccharide reduction. For the definition of monosaccharide reduction, it's the carbonyl group in aldose and ketose that can be reduced by sodium borohydrate to 1 degree and 2 degree alcohol, respectively. The product of this reaction is a polyalcohol called an alditol. Monosaccharide reduction is one of the important ways that monosaccharide can react. Sodium borohydrate is used as a reducing agent, as it is one of the most common reducing agent and a weak reducing agent. Next, for the reaction, dimanose is reduced with sodium borohydrate, and then H3O plus is used to quench the negative charge and add 2 proton, or we know it as a protonation step. And then dimanose is reduced into a mannitol. And for the glucose, when it is reduced by sodium borohydrate, it becomes into sorbitol. But when we reduce the fructose, it formed 2 products due to C2 racemization, and it produced mannitol and both mannitol and sorbitol. The reducing action of monosaccharide depends on the free anomeric carbon in their molecules. For the use of product, alditol are used industrially as a sugar substitutes, as a food thickeners, and medicinally as laxative.
Next slide. The definition of hydroxyl group reaction is a hydroxyl or hydroxyl group is a functional group with the chemical formula of one hydrogen and composed of 1 oxygen atom covalently bonded to 1 hydrogen atom. In organic chemistry, alcohols and carboxylic acids contain 1 or more hydroxy groups. Next slide. And the function is they readily participate in a hydrogen bonding, generating either a net positively or negatively charged ion. This group can also participate in chemical reaction to link molecules together, forming chains of sugar or fatty acids. Next slide.
Okay, next we are talking about the reactivity of the hydroxyl group. The hydroxyl group, the hydroxyl functional group itself is additional molecule that can add on into a molecule that can give a property. And in this case, hydroxyl group can give a polar covalent bond. Why? Because if we look at the OH relationship, it doesn't have the exact electronegativity that results in the oxygen and hydrogen relationship. Forms partially charged somewhere in there, and if we look inside of it, oxygen is more greedy than hydrogen, and this results the hydrogen forms a partially positively charged, and oxygen forms a partially negatively charged. Next slide. And the forming of the polarity, the forming of the partial charge between oxygen and hydrogen, uh, it can it results in the polarity. It results in the polar covalent bond, and it can bind with water because why? Next slide. Because if we look at the molecule of water, which contains two hydrogen atom and one oxygen atom, which the oxygen atom have partially negatively charged that can bind with hydroxyl group. And if we look at the example, next slide. If we look at the example of methane, for example, the carbon, the atom, the molecule that cannot bind with water because there's the relationship between carbon and hydrogen has the almost exactly same electronegativity between them. And if we change the one of the hydrogen with a hydroxyl group, like in the right hand side, OH, it forms a partially positively charged in the hydrogen, and it can bind with the oxygen, which have the partially negative charge. And the methane that we add a hydroxyl group becomes methanol. Why? Because the hydroxyl group changes the molecule into an alcohol. Next slide.
And next to the glucose structure determination. Next slide. Glucose and how it's formed is that glucose is a group of carbohydrates, which is a simple sugar with a chemical formula of C6H12O6. It is made of 6 carbon atoms and an aldehyde group. Therefore, it is referred to as an aldohexose. It exists in two forms: phase open chain, acyclic, or form or ring cyclic form. Next. And these are the structure of the glucose determination group. Next. Glucose is a simple sugar with the molecular form of C6H12O6. Glucose is the most abundant monosaccharide. Subcategory of carbohydrates, glucose is mainly made by plants and most algae during photosynthesis from water and carbon dioxide, using energy from sunlight, where it is used to make cellulose in cell walls, the most abundant carbohydrate in the world. Thanks. The reaction is the test for glucose involves a double sequential enzyme reaction. In the first reaction, glucose oxidase catalase the oxidation of glucose to gluconic acid and hydrogen peroxide. Then the peroxidase in the glucose bed catalyzes the oxidation of a chromogen by the hydrogen peroxide to form a colored product. Next.
Okay, so the saccharides are carbohydrate that form to monosaccharide. The said compound form through reaction which release water to form an oxygen bridge between. The example is maltose structure here. You can see the oxygen bound here. Next slide. Okay, so this is the formation process, which is the process is called dehydration synthesis. So the hydrogen group from one molecule and another hydrogen group from a sugar molecule react to construct a bond between the two molecules, releasing water by employing an oxygen atom as a bridge between the two molecules. And here is the example. Next slide. Okay, so the classification of the saccharide is divided into two, reducing and non-reducing. Reducing sugar are carbohydrate that, due to the presence of free aldehyde or ketone group, can act as reducing agents. Example, maltose and lactose. And non-reducing sugars are carbohydrates that cannot act as reducing agent because they lack free aldehyde or ketone group. Example, sucrose. Next slide. And here is the example and function. Maltose. Maltose formed from glucose plus glucose, which result in maltose plus water. It often found in natural foods such as potatoes, starch, and it plays a main role in our digestions. And it's connected by alpha 1.4 uh, glycosidic bond, and it's a reducing sugar. Next, lactose from glucose plus galactose, which result in lactose plus water. It often found in milk, and it's the main energy source for mammals. It connected by beta 1.4 glycosidic bond, reducing sugar. Next, and sucrose. Sucrose is consist of glucose plus fructose, which result in sucrose plus water. The example is general table sugar. It connected by alpha 1 beta 2 glycosidic bond, and it's a non-reducing sugar. Next.
Okay, the next topic is polysaccharide. Polysaccharide is a large molecule made of many smaller monosaccharides, and it is a polymer of simple sugars that can serve as functional and structural components of cells and can also be used as an energy source. And this will be discussed in the later slides. And special enzymes bind small monomers together, creating large sugar polymers or polysaccharides. And this can also be interpreted in created with glycosidic bonds. Next slide. The structure. All polysaccharides are formed by the same basic process. Monosaccharides are connected via glycosidic bonds, and the structure of the molecules being combined determines the structure and properties of the resulting polysaccharides. This means that the structure of polysaccharides can determine the function of the polysaccharide itself, whether it can be used as a energy storage or structural polysaccharide, which we can see in plants and so on. And the example that we can see is in the right hand side, which have a straight polysaccharides that creates a strong structural that creates a strong structure. Next slide. And here we can see two types of polysaccharides. The first one is homopolysaccharides, which composed of one singular type of monosaccharide. We can see that here is amylose and amylopectin that we can find in starch. And the second type is heteropolysaccharides that are composed of more than one type of monosaccharide. And one of the example is hyaluronic acid. Next slide. And the functions commonly it have two functions, which is energy storage and structural support. The first one is energy storage. Enzymes that produce the background is the enzymes that produce energy only work on monosaccharides stored in polysaccharide because polysaccharide cannot it folds together and contains monosaccharides that produce energies, and this we can define it to a storage or energy storage because the energy is in the polysaccharide itself. And the second one is structural support. The polysaccharide can be mixed with any number of other components to create tissues that are more rigid, less rigid, or even materials with special properties. And these are composed. We can see this in cellulose, chitin, which is heteropolysaccharide, and these are all non-starch polysaccharides. And we can see the structure of the polysaccharide itself in the right-hand side, which is amylose and cellulose that we can find in plants. Next slide. That is all for from group 2. These are the references. Thank you for listening. Thank you for listening, and goodbye.